Okay, as we look at this one, what is the clue that there's the problem or a difficulty with this problem? Remember, there's the situation. This is the situation where we have two sides and one angle. If it were the other way around, two angles and one side, there's never any issues, because if you have two angles, of course, you have all three. But when you have two sides and one angle, you have to check the side opposite the angle. So the angle we have here is angle A. That means we are looking at side A. And what you have to check about it is that opposite side smaller than the other side? So the other side here is the 37. So yes, that opposite side, A of 19, is smaller than the other side of 37. So what that is telling us is that one of two things is going to happen. If that opposite side, in this case side A, is too short, it's possible that it does not form a triangle. In this case, that's not a problem. It does form a triangle. Remember what we said is it could not form a triangle if we have this angle here, angle A, and side little b. It's possible that side little a is so short it can't possibly reach back down to the other side. That's not a problem in this case. The other option, the other possibility is there are two possible triangles. And that is actually the case here. There are two possible triangles. So when we go to construct this or go to solve it for the other pieces, we actually need more information. Here's angle A, which is 28 degrees. This up here is going to be side little b, which is the 37 inches. Side A can either go like this. I'll do this in a little bit later. It can either go like this, or it could go like this. So what we need to know, this is angle B down here. What we really need to know to solve this triangle is angle B acute, which would be this one, or obtuse, which would be that angle. So for the sake of argument here, we're going to say we are told that angle B is obtuse. The 113 is what it comes out to be. All right, let's go through how we found that. This is the 19 inches for side A over here. This is going to be angle C inside little c.
Are you deciding that it was obtuse?
I had to tell you that it's obtuse. I had to just give it to you. You either have to have a picture like this that shows you that it's obtuse, clearly shows you it's obtuse, or you have to be told that it's obtuse. Yeah. And this one, yeah, we weren't given a picture. So you had to either be told it's obtuse or acute, or you have to solve it both ways and give both answers. Now on our tests, I will usually give you a picture or I will tell you. Okay. So then, we have side A, which is 19, over the sine of angle A, which is 28 degrees, is going to equal side B, which is 37, over the sine of angle B. So now we are solving here for a missing angle, which means we're going to cross multiply and divide, but then we're still going to have to do an inverse sine. So it'll be the sine of 28 times 37 divided by 19 is going to give us the sine of B. So we get 0.9142, which tells us that B is the inverse sine of 0.9142. So second answer, 66.1 degree looks like. So if that's what we get there, now remember we said B is obtuse. So since B is obtuse, it's actually 180 minus 66.10 degrees, which is 113.90 degrees. So with that being 113.90, angle C up here can then be found by doing 180 minus the 113.90 minus the 28, which is going to give us 38.10. Degrees. And now we're back to finding a missing side C. So I'm going to start out again with my ratio. Length of side A is 19. Sine of angle A, so sine of 28, equals side little c over the sine of angle C, which is 38.10 degrees. So once again, we're going to cross multiplying and dividing. 19 times the sine of 38.1 divided by sine of 28. Oops, sorry, parentheses in here. $24.97 I'm getting. That's inches. Now let's go back and double check and make sure this makes sense. Our smallest angle here is the 28 degrees. 19 is the smallest side. Largest angle is the 113.9. 37 is the largest side. So it makes sense. Now that doesn't catch every mistake, but it catches the really silly ones if you do that. So we have to be very careful for that case. Whenever we're given two sides and only one angle, we have to always double check, is that opposite side, that side opposite the angle, the smaller of the sides or the larger of the sides? If it's the larger one, we're okay. If it's the smaller one, then we've got to check to see the two possibilities. So here I'm going to give you a triangle. I'm going to tell you that angle C here is 33 degrees. I'm going to give you the angle A is 41 millimeters. And the angle B over here is 52 millimeters. And I want to find my missing pieces. So now here is another case where we have two sides and one angle. So we got to check, is the side opposite the angle the smaller or larger of the two sides? We don't have the side opposite the angle here, do we? This is going to be law of cosines. So here, the two sides are not the side, neither one of them is the side opposite the angle. So that means we cannot use law of sines here. We have to start out with law of cosines. The law of cosines is actually part of the Pythagorean theorem. It's sometimes called the generalized Pythagorean theorem. Because if the angle that we're given is a right angle, 90 degrees, this becomes the Pythagorean theorem. And I'll show you what I mean. So C is the side that is opposite the angle that we are given. The length of C squared is equal to the length of side A squared plus the length of side B squared. So far it's looking exactly like the Pythagorean theorem, but then there's an adjustment factor. Minus 2 times the length of side A times the length of side B times the cosine of angle C. Now, if C is 90 degrees, what is the cosine of 90 degrees? It's 0, right? So if C is a right angle, in other words, 90 degrees, this becomes 0, and it is just the Pythagorean theorem. That's why we say it's the generalized Pythagorean theorem. But if C is a right angle, we're not worried about that other term. We're just going to use a squared plus b squared equals c squared. Because the sine of C is 0, and anything multiplied by 0 would be 0.
Of whatever angle you have, right?
Yeah. So since this C is not 90 degrees, we have to have this adjustment factor here. So we're going to use this law of sines, and what it's going to, or this law of cosines, and what it's going to do is it's going to find this side for us. Once we have the length of that side, then we can go back to using the law of sines for the rest of it. So side C squared is going to equal, A is 41, so 41 squared, plus B is 52, so it's 52 squared, minus 2 times A is 41 again, times B is 52 again, times the cosine, C is 33 degrees. Now when I punch this in the calculator, I'm going to do it just like I do Pythagorean theorem. Instead of putting the squared here, I'm going to make this whole thing under the square root. So when I enter this in the calculator, I'm going to start out with second square root. 41 squared plus 52 squared. Do not hit equals or enter at any point in this calculation until we are totally done. If you hit equals at any point, it will mess it up. Minus 2 times 41 times 52 times the cosine of 33. Now I have everything entered. I'll hit equals. It gives you 28.44. And that is going to be millimeters. This whole thing has to be underneath the square root. Yes, so everything. This doesn't have to be in parentheses. No, just the parentheses that you get when you start the square root, you just don't close it to the very end. Everything else should be able to run through in one. If your calculator puts parentheses around the angle and your cosine, you may have to put 2 parentheses at the end. So this side C is 28.44 millimeters. Now that I have side C, I can find angles A and B because I now have a side and its opposite angle. 28.44 millimeters over the sine of the 33-degree angle equals, now, which side do I want to use first? It doesn't matter, except here, looking at B, I'm not sure if B is just less than 90 degrees or just more than 90 degrees. So the safer bet is to always use the smaller side. Because I know that there can only be one angle in a triangle that's obtuse. So the only angle here that could possibly be obtuse is angle B because it's opposite the longest side. So I'm going to find the smaller angle first using the smaller side, which is the 41. Yeah, then B is going to be found by subtracting from 180, so I don't have to worry when I do the inverse sign, whether it's obtuse or acute. It's just going to be found by subtracting. So now I'm going to cross multiply and divide sine of 33 times 41 divided by 28.44. Gives us 0.7852. So A is going to be the inverse sine of that. (51.74 degrees). So now I can find angle B by doing 180 minus 51.74 minus 33. Which is 95.26 degrees. So it actually was slightly more than 90 degrees. So if I had tried to find angle B first, a good chance I may have just said 84.74 degrees and I'd have been wrong. So that's 95.26 degrees for angle B. And that's it. We've solved the triangle. So here I'm going to give you angle B is 118 degrees. Side A is 33 millimeters. Side C is 31 millimeters.
Is there anything different to this process?
This is the same process. The only thing different right now is the way I labeled it. Instead of giving you angle C, I gave you angle B. All you have to do here is just rearrange it. Because the formula was C squared equals. Well, here now we're going to use, instead of C, we're going to use B. So here it's going to be B squared equals the 33 squared plus the 31 squared. So the two sides that we're given. Minus 2 times, we put those sides in there again, and the cosine of that angle, 118 degrees. Because the angle is still between the two sides. We don't have a side opposite the angle. So the process is still the same. So it doesn't have to be side C. It can be rearranged. Anytime there's an angle between two given sides. So again, I'm going to cross off that squared and I'm going to put a square root over here. So B is the square root of 33 squared plus 31 squared minus 2 times 33 times 31 times the cosine of 118. 51.97 millimeters, side B. Now here, the angle that we have is an obtuse angle. So we know the other two have to be acute. So when we go back into the next step to do the law of sines, really doesn't matter which one I use. So the 51.97 is over the sine. Its opposite angle is the 118. But just out of force of habit, I still am always going to take the smaller side. The 31 is going to be over the sine of which angle? C. So we're finding the sine of angle C here, and then we'll come back to find C. Like I said, it didn't matter which side I used here, but I want you to be in that habit of taking the smaller side. So sine of 118 times 31 divided by 51.97. This is 0.5267. So C is the inverse sine of 0.5267. So second sine, second answer. 0.3178 degrees. Oops, not degrees. Yeah, it is degrees. 31.78 degrees. Then for A, 180 minus the 118 minus the 31.78 is what, 30.22 degrees. Something doesn't make sense there, does it? Why do I say that? This side's longer than this side. This angle should be bigger than that angle. So I know I must have done something wrong. So somewhere in here I did something wrong. What did I do? Let's double check this one here. $31.78 I'm still getting. Sometimes because these are so close together, there's a chance that round off errors could have got me, but I'm going to double check this calculation again just to be sure. This 51.97? Yeah, I'm thinking that's got to be where the mistake is. Yeah. 54.87 is what I'm coming up with now. So that means that's going to be wrong. And we'll go back to that point there and start over. So 54.87 is that side length over the sine of 118 equals, again, we'll still stick with taking the shorter one, 31 over the sine of C, and we'll cross multiply and divide. .4988. So the inverse sine, 29.92 degrees. So then angle A is 180 minus 118 minus the 29.92 degrees, which is going to give us 32.08 degrees, which makes more sense. So you can see there that double check I've been doing of checking to make sure the smallest side's opposite the smallest angle, longest side's opposite the longest angle. It's not going to catch every mistake, but I don't know what I did wrong when I punched this in, but I obviously did something wrong. I punched in something wrong. So it catches some of those, a lot of those mistakes it'll catch. I'm going to have you guys try one of these, see if you guys have it down. Find the missing side and the two missing angles for this triangle. I'll give you a couple minutes, then we'll come back to it. Okay, so well, this time we're looking for side A over here because that's the side opposite our angle. So it's A squared equals, then the 82 squared plus 119 squared minus 2 times 82 times 119 times the cosine of the 19 degrees. Again, I'm going to cross off that squared and I'm going to put a square root over here so I can solve it all in one step in my calculator. We enter it in our calculator just like we have been. We get the side A is 49.32. This is 49.32 millimeters. So now when I go to find the next angle, I have that 49.32 over the sine of 19 degrees. Which side do I want to use next, the 82 or the 119? The 82, always use the smaller one. So that'll be over the sine of angle C. So we'll cross multiply and divide. So sine of 19 times 82 divided by the 49.32. So we get 54.13, or 0.5413 I should say, is the sine. So then we do inverse sine of that. 32.77 degrees. Angle C here is 32.77 degrees. So then angle B is 180 minus the 19 minus the 32.77. 128.23 degrees. What do you think? Now there are other uses for this law of sines. But for right now, I'm going to hold off and we're going to come back to those uses tomorrow. So for right now, it's in that packet that you have, page 382 to 385. We had done 1 through 17 last time for law of sines. Now we're going to be working on 18 through 42. I will warn you on this one because it may come up in the homework assignment. The case that we did not go over yet, there's one other place where law of sines can be used, and that's if you're given all three sides. If you're given all three sides, you can actually use the law of sines to find a missing angle. We haven't done that yet. So if you come across one in the homework where you have all three sides and no angles, you can skip that one because we're going to come back and do those tomorrow. So I'll let you guys have the last 14 minutes to get started on those.